Hi guys, in this video I'm going to talk about the modulation sources in SynthMaster 3. But before going into the modulation sources, I will explain modulation in general and also the modulation architecture in SynthMaster 3. Let's start off with the init presets, which basically consists of a single layer with an oscillator, basic oscillator, and the state variable filter. So here on the modulation matrix part, I see ADSR1. ADSR1 is basically connected to layer 1 volume parameter. This is the final voice volume parameter. And we need to connect an envelope basically to this volume parameter so that we can terminate a voice. Otherwise, our voice would play forever. And here on the mod matrix entry, we see amount, curve, and type parameters. So the mod amount is basically the modulation amount. For multiplication type modulations, at the maximum value, it goes from 0 to 1. But at lower values, for instance, at half value, it goes from here to here. So for instance, if I play this voice, it will not terminate. Let's try this. You see, it is stuck at this level because the modulation is not at full value. So I'm gonna, as you see, when the value reached almost to 0, the voice was terminated by SynthMaster's algorithm, voice termination algorithm. So what is modulation? Modulation is basically changing the value of a parameter over time, and we need modulation to create sounds. Modulation is a fundamental part of sound design. By default, we have a single modulation in our init preset, which is this envelope connected to this volume parameter. So I can do stuff like I can change the attack, decay, sustain, and release values so that this volume can change over time like this. So this is how modulation works. We need to change the amount of a parameter. We need to modulate it to create sounds. In SynthMaster, we have 5 different modulation sources. The first one is an ADSR envelope. ADSR envelope consists of attack time, decay time, sustain level, release time, and also this envelope lag. We have different types of ADSR envelopes. We have, by default, we have a digital envelope, but we can also have analog envelopes here. We have FATI, ProFat, and OB, and these envelopes behave differently, and they have different attack, decay, and release times, and also different sustain levels compared to the digital envelope. So I will stick to the digital envelope for now, and let me first turn off this filter. And now I am going to play with this attack, decay, sustain, and release parameters. So this attack value can go from the minimum value is, I guess, 4 milliseconds or something, and it can go up to 20 seconds. It increases exponentially. The same is true for decay time and release time. And also the attack, decay, and release parameters can have slopes like this. So I can have an exponential attack like this. Or I can have a linear attack. We can also adjust the envelope amount here. Basically, this envelope amount here, you can think of this envelope amount as the volume of the envelope. So by changing the envelope amount, I'm controlling the volume of the oscillator. We also have a lag parameter here. So if I increase this lag, you will see that this ADSR output is filtered. This is basically a low-pass filter used to smooth the output of the envelope. We can also sync the envelope times, the attack, decay, and release times to our tempo. For that, I have to turn on the sync button. And there's a snap setting here also. By default, it's off, but I'm going to set it to quarter notes so that I can snap the attack, release, and decay times to quarter values. So if I change my tempo here, for instance, my tempo is at 120. If I make it 240, these timings will change. But if I make it 120, the time doubles with slower tempo. So yeah, as I said, you can sync the ADSR times to the tempo. And you can also make this envelope a one-shot envelope. In the one-shot mode, the entire envelope renders. If it's not a one-shot envelope, if I release the key before I reach the sustain stage, we continue from the release stage. As you see, it is we can visually see. But if it's a one-shot envelope, the entire envelope runs. So regarding the envelope types, I'm going to turn on the filter and create another ADSR envelope and assign the cutoff frequency to this envelope. So this actually acts like a filter envelope. And let's also change this and turn lower envelope lag, and let's have no decay. It's a full sustain. Oh, it's not a one shot. So let's add decay to this filter envelope, like a long decay. Sustain and release. So this is the digital one. Now if I switch to another one, for instance, for these analog envelopes, we have either this exponential or close to, this is not exactly linear, it's close to linear. We have slopes like this. We don't have the slopes that we have in the digital versions. So let's try this. So let's see. Oh yeah, I can see the difference clearly. So this release is, for instance, this release is let's make it 3 seconds. Okay. In the default, in the digital envelope, I have a release with 3 seconds. But if I switch to fatty, this time it goes down to 2 seconds. If I choose digital, it's 3 seconds. As I said, the envelope times are different because we analyzed those synths, we analyzed their envelopes, and these are the timings. We also have ProFat, for instance. We also have OB. OB has a longer curve. So based on your sound design goal, you can play with these envelope types. Okay, so this is so much for the ADSR envelopes. Next, I'm going to talk about the multi-segment envelopes. I am now going to delete this modulation source and create a new one, this time of multi-stage envelope. And I'm going to drag and drop this multi-segment envelope over the filter cutoff. So as the name suggests, this multi-segment envelope consists of multiple segments, multiple line segments like this. It's a digital envelope. It's not analog or anything like that. And you can just click on a rectangle here and move it around like this. And if you want to add a new point, you just double click on an area, empty area like this, and that is added. Or if you want to delete an existing point, again, you move your mouse over the rectangle and right click to delete. This is how you can add or remove points. And of course, you can undo or redo your add or remove edits. Now I'm going to by the way, this line here you see is the sustain point. And just like in ADSR envelopes, we have the envelope amount and the lag parameters. But we also have other parameters specific to the multi-stage envelope. For instance, we have the loop start and the loop end. And to explain them, I'm going to add some points here. And I'm going to set the loop end to the 4th point or 5th point. And now the color of this area changes because I turned this envelope into a looped envelope. But I want to make them shorter like this. If I move my mouse around, I can also change the loop point like this. You see, I can change the loop ends or the loop start points. Let's, for instance, start from here. And let's also add another point here, so we can demonstrate multi-stage release. Here we have the loop count. By default, it's infinite, but I can actually make it between 1 and 32. Oh, I can also make it off. If I make it off, this is going to be a one-shot envelope. Let's first try that. Now it is a one-shot envelope. Let's, for instance, make it loop 2 times. I think there's a problem with the loop count. It's counted up to 3 times, but it's okay. It's a bug. I will fix it. It is supposed to go 2 times only. But you get the idea. I mean, this is how it works, basically. And also I can click on this zoom icon so that I can edit this graph in more detail. I can also sync these envelope times to the tempo. And let's, for instance, sync to quarter notes. to 4. So let's delete this one. Okay. Like this. And yeah. Now I tempo synced my multi-stage envelope. And this is so far for the multi-stage envelope. Next, I'm going to talk about the low-frequency oscillators, the LFOs. I am now going to delete this modulation source and create a new one, an LFO. So, LFO stands for low-frequency oscillator. It's basically an oscillator, just like these basic oscillators, but it runs at a slower rate. Actually, speaking of slower rates, the modulation sources in SynthMaster, they don't run at audio rate. They run at what is called block rate. So what is a block? A block is a fixed, a certain number of samples. And how do we set this block? We set it from here, the engine buffer size. By default, it's set to normal. Normal is 32 samples at 44 kilohertz sampling rate. And 32 samples is normal. And if you make it small, the number goes down to 16 samples, so that the modulation sources are calculated at every 16 samples. You can also make it large, which is 64 samples, or you can set it to X large, which is 128 samples. I usually, by default, it is 32 samples, and if you increase this number, SynthMaster's CPU usage will actually decrease. But if you have sounds that change abruptly, like plugs or some bass sounds, I don't recommend increasing this value higher than normal. But if you have sounds like pads, or keys, you can set those presets to large or X large values. Pads are suitable for X large. Anyhow, I'm going to set this to normal again, to 32 samples, and continue from where I left off. Yeah, I created an LFO. So an LFO is basically, it's a single cycle waveform, just like our basic oscillators. I can even draw my own shape using the waveform editor. So if I want to create a noisy sine wave as an LFO, I can do that. And this is my LFO now. And I'm going to drag and drop this LFO over the filter cutoff frequency. And now I created a new modulation. And right now, when I run my LFO, there's a position indicator that's changing in real time. So this indicator is changing in real time and is showing me the position of the envelope. And by default, my envelope is set to 1 Hertz. So the frequency of this sine wave is 1 Hertz. It changes once per second. I can change this value between 0.01 Hertz, which makes a period length of 100 seconds, to 100 Hertz. So if I increase this value, this engine buffer size is important. So let's make this small and try again. And let's make it large. Okay, I don't hear much difference. Maybe it's because of the speed. It's too fast. Anyhow, so I can change the speed between 0.01 Hertz and to 100 Hertz. I can also sync the speed to my DAW tempo. I can do it like this. So when I synced it, right now my period length, my LFO length is 4 over 1. So 1 over 4 is a quarter. This is a whole note, so this is 4 whole notes. I'm just going to make it a whole note. So this is 4 bars at 4/4 tempo. And I can also half this tempo from here. Set sync speed to half or quarter. I can also do that. I added this menu to set it exactly, because when you use your mouse, you cannot set it to an exact amount. That's why I added that. We can also use triplets. And of course, I can change the shape as I wish. And here I can apply a low pass filter, which is actually similar to this one. Anyways, I'm gonna stick to the basic sine wave. And now I am going to add some noise to this LFO. Yeah, I can do that. I'm adding white noise to this LFO. So what we can actually do is we can, for instance, we can use the mod wheel to add, we can use the mod wheel to turn on or turn off the noise amount here. So with mod wheel at the lowest value, we have a noisy LFO. But if I increase the mod wheel, I'm going to have no noise. I can also use the mod wheel, for instance, to control the speed parameter. Let's, for instance, change this to 1/4. So I can create rhythmic effects like this. I can also apply sample and hold to this LFO like this. So this is my sample and hold interval. Let's, for instance, use the mod wheel also to increase the sample and hold time. Wait, I'm gonna have to increase this sample and hold time. Anyhow, I'm gonna turn off this sample and hold, and there's also this gate parameter. So you can you can apply a gate to the LFO waveform using this gate. The LFOs in SynthMaster, they have their own envelopes. But these envelopes, they're not ADSR envelopes. They are delay, attack, and release envelopes. So for instance, let's have 0 delay, but some attack, and then some release. And also the envelopes have a final value parameter. By default, this envelope is at maximum level when it reaches the end. But you can also turn it to 0. So I'm going to attack, I'm going to attack for 1 second. Let's actually make this 2 seconds, for instance. So in 2 seconds, my envelope, my LFO will reach full value. As you see, I'm applying this envelope to the LFO. And also this release, 2 seconds release. And when I release, the envelope volume is decreasing, so that the LFO modulation amount is decreasing. Okay, so this is what the envelopes, how the envelopes work for the LFOs. And I also talked about the parameters for the LFO. And there's one final parameter, which is the phase parameter. So this determines the start value of the envelope, the start offset of the envelope, just like the oscillator phase. Now, there's a common parameter for all envelopes and also LFOs, which is the trigger parameter. So by default, this trigger is poly. So poly means that it's polyphonic and it's per voice. We can also set it to random, for instance, and if it's random, the LFO starts at a different phase. It starts at a random position. So if I press, for instance, 3 different keys, their LFOs will start at random values. Now compare this with poly. They all start from the same phase, but if it's random, they start from different phases. And aside from poly and random, we have global and mono. So if I choose mono, basically the envelope, the LFO and its envelope is re-triggered, their position are reset whenever I press a key and there were no keys playing before, like this. So when there were no keys playing, if I press a key, I re-trigger the LFO. There's also this global setting. If it's global, the LFO is re-triggered at the beginning of the song, and it is never triggered again, just once. That's what global is for. Let's try to restart. Let's make the final value maximum. So as you see, global and mono are similar, but global triggers only once at the beginning of the song when I rewind back and start the play button in my DAW transport controls. But when it's mono, whenever there were no keys playing and I press a key, and this is how the mono re-triggers. Basically, it starts from the beginning. Okay, so this is so much for the LFO. Oh wait, there's one more thing. I'm sorry. By default, this LFO has a single shape. And because it's single mode, it's in single mode. There's also a double mode. In the double mode, we have two different shapes. And using the crossfade, I can switch between shapes. So let's use the mode wheel to go from this shape to this shape. So this is how the double mode works. You have to use the crossfade to switch to the crossfade between these two waveforms. Okay, guys, so much for the LFOs. And next, I'm going to talk about the noise LFOs. I am now going to delete this modulation source. Delete. And create a new one. This time, a noise LFO. And I'm going to modulate the filter cutoff again with this modulation source. As you see, right now it is generating noise, step noise. And it is synced to tempo. So let's change this. This is the duration of these steps. I'm going to just start from half tempo, for instance, and use the mod wheel to change the speed. So here I have different settings like bits, attack, and release. So attack is basically the attack time. This is a ratio of the entire step length, and there's also a release time. Let's increase the attack and release. So here it says linear. So I have a linear attack and linear release. I can also choose exponential like this. So I have a shorter attack and faster release. I can also lower this bits value to change the output resolution of the generated white noise. So I can apply bit reduction on the generated white noise like this. For instance, let's make it 4 bits, 2 bits actually. That's the minimum value. This is 3 bits, so I can have 8 different values. So here I have the noise color setting. I can, by default, we have white noise, but we can have other types of noises. I can have brown noise. Or violet. And I'm going to increase the bits. I can also have an exponential linear attack and exponential release like this. I can also have a bipolar LFO, so that by default it's unipolar. The value of the modulation source is between 0 and 1. 0 and 1. But in bipolar mode, let's have this value here like this. In bipolar mode, the modulation source value is between -1 and +1. So let's compare white noise and brown noise. You see how it fluctuates, and look at the purple noise. It fluctuates less. And brown noise, it fluctuates less because it's brown noise, it's less noisy. And just like the LFOs, the noise LFOs, they have their own envelopes. So I can have an attack followed by a release, and I can have a final value. I can also turn off the sync. Let's clear the modulations here. And I can set the speed to maximum, so I can basically run this as a regular noise. So this is basically how the noise LFO works, guys. And in my next video, I'm going to talk about the step LFO. I am now going to delete this modulation source and add a step LFO. So as you see, the step LFO is like a multi-segment envelope, but we have this time steps with fixed lengths. Let's turn on the tempo sync so that each step is actually a quarter note. And let's use this step LFO to modulate the filter cutoff. Just like the MSEGs, each step can have different each step can have different slope. Let's start from here. This is sort of like an attack. Now here I see 1, 1, 1, 1, 1 below each step. What I can do is this is the step length basically. I can make this like I can reduce the step lengths like this. As you see, when I decrease the step lengths, I halved the step length actually by making it 1/2, so that it's repeated 2 times. When I set it to a quarter value, then it's played 4 times. So basically, if you set the step length to 1/n, it repeats n times. And by changing these amounts, you can create really rhythmic effects. Let's also use triplets here. So I combined half, quarter, and triplets. And just like in envelopes, I can add a lag. Let's actually modulate this with our mod wheel. And I can just like in the LFOs, I can apply a gate to each step. And also, this sequencer, the step LFO, it loops. Basically, I can change the start step like this, or I can change it from here. So for instance, let's start from the beginning. And just like other LFOs, the step LFO has its own envelope, so that we can have it can have its own attack and release values. And just like the other modulation sources, it can be bipolar, or it can have different trigger settings. Like we can have a mono step LFO. And also we can add randomness to each step using this random parameter. So this is basically how the step LFO works. And just like the multi-stage envelopes, the step LFOs, they can have they have this larger window, which is useful to edit these steps in further detail because it has larger area. And here on this pop-up window, we see all of the parameters all together, like the envelope parameters and the step LFO parameters. They're all here. Okay, so this is so much for the step LFO. And finally, I am going to talk about the scalars as a modulation source. To explain the scalars, I'm going to delete this step LFO and create another basic LFO. And after the LFO, I'm going to create a scalar. So basically, the scalar is similar to the key scalar that we had in SynthMaster 2. SynthMaster 2 featured four scalars per layer. But in SynthMaster 3, we decided to call this scalar because it has dynamic input now. The key scalar in SynthMaster 3 only had a single input. It's the key track modulation source. The key track modulation source is under MIDI basically. It is basically the MIDI note that you are playing. And to preserve backward compatibility, of course, by default, it's set to key track. So let's actually. Oh, this time I'm not going to modulate the filter cutoff, okay? I'm going to turn off the filter. But this time, for instance, let's actually modulate the pulse width. The pulse width of the oscillators using this. So right now this is a linear curve. And if I add I'm pressing a low key and now a high key. You see the pulse width changed because at low keys, I'm sorry, there's a bug here. It doesn't show me where it is supposed to be. So based on this input value, I'm actually using the scalar sort of as a wave shaper. It's shaping its inputs using this curve. The pulse width is changing based on this curve. But what if I change this source to something else? But first, let's do this. Let's add some grids here. And let's also add some points. So you see the points shouldn't, the line segments don't have to be connected. If you want to make them connected, just press this tie. Okay, I now pressed the control key to make the line segments connected, and they were connected automatically, okay? For instance, let's make this curve like this. Okay, now I'm going to have this triangle LFO, okay? So basically, I have a value that's going up and then that's going down. This is my LFO. So what if I choose this triangle LFO as the source of my key scalar? LFO 1. So basically, the LFO shape is the LFO renders, and then the scaler uses the LFO, and it distorts, it wave shapes the LFO shape using this curve. So I think this is called modulation remap or something in other synths like Vital, but this is basically how you can achieve the same thing using the scaler. As I said, by default, the key track is the default source for the scaler, but you can just use another modulation source as its input. So you get the idea. This is how the scaler works basically. It's a very simple modulation source, but I believe it's very unique and effective if you combine it with other modulation sources. So guys, this is so much for this video. I hope I explained the modulation sources and the modulation architecture in detail. And thank you for watching me.